Hi, I'm Sportster Paul. Today we're going to talk about the free CAM, Computer Aided Manufacturing Package, that's in Solidworks. It came in Solidworks 2018, 19 I used 20. It's made by CAMWorks. It's not fair to call it crippleware. It's a pretty decent package. It seems to me to be limited just to mills, won't do 4-axis, won't do lathes. But it's got a lot of features and stuff to go through. This is just my first impressions. It's got all this automatic stuff, which I don't like. So I'll go through and show you what it wants to do and how you end up fighting it to get it to do what you want. All the automatic stuff for me didn't play out. I think I'd rather get a simpler package that I just do every operation by hand so I know where it is and I know what it's doing. So let's look at what we got going here. First off, tools, go down here, add-ins. I lost it. There it is, add-ins. So SolidWorks CAM, you turn it on in the add-ins here. SolidWorks CAM, there it is. I don't know, I asked a friend what Composer and Forum is. It's pretty cool stuff. I'm leaving it turned on. So that checkbox here, make sure that it comes up. What that does is add these 3 tabs to the tab bar here in your SolidWorks. Feature tree, SolidWorks CAM operation tree, SolidWorks CAM tools tree. Tools tree is already populated. They default to tool crib 2. There's 23, I think, 23 tools in there. This isn't too bad. A little exasperating because I should mention, I'm an engineer, I'm not a machinist, and I have 0 CAM experience. So you see me getting frustrated and ranting about this. It's more my inexperience than anything wrong with the program. So the other trick I learned, watching a lot of tutorials, enable command manager. So you go up to the toolbar. Let's turn it off first. Turn it off. I prefer the vertical space, but when you're learning something, it actually might pay off to go right click, enable command manager. It's one of these ribbon deals like Microsoft did with Word decades ago. Everybody hated. But there's a sense to it in that it helps you kind of walk through the procedure you're supposed to use to do what you're trying to accomplish. And for somebody brand new at the software, it's not a bad thing to turn on and eat the vertical space up. So here's a solid model. This is something I imported. I downloaded it off the internet. It's a flanged nut for a ball screw. I think it was a solid part because it came in with, it's not a chunk, although you could import a chunk here. It doesn't need features in the CAD sense. The CAMWorks will extract the features for you, bosses, holes, things like that, even if you just brought in a solid chunk from an IGES file or something like that. But this one has real features, boss, revolves, clearance holes, all of this stuff. Here is the feature tree where CAMWorks, where either you would create by hand features that you, okay, this is a feature, this is a hole. This is a feature, this is an open pocket. This is a feature. CAMWorks does it all automatically and they brag about it and programmers think that's cool. I hate it, but you be the judge. Let's go through it and let it do its thing. One thing that kept confusing me, here's the operation tree. This is where it says, okay, center drill, peck drill, two tools to do one feature. Unfortunately, like right now, it's really confusing. See, they're identical. So how do you know what you're looking at if you don't look at the tiny little shaded distance? So that's an irritation. Universal, I guess, to SolidWorks. So in theory, it says define the machine. So if you go left to right, okay, it's trying to help us define the machine. I've got a problem. This is a 4-monitor setup. I'm only doing a recording on one because you can't watch 4 monitors. If I have this dialog box that just opened, when I press that button, the define machine dialog box, if I close it right now, the next time I go to open it, it's 5 miles off on no monitor. I got to go hunt monitors and find it. Or let me show you real quick, because if I get this problem, you might have it too. Screen resolution. Then here are my 4 monitors. We're working on 3. I found, one of the places that those dialog boxes reappear, if I come over here and apply, then I see them. Sometimes I have to go over here and apply and see them. We'll just cancel out of this. The other trick, absurd as it sounds, you go to edit the registry, regedit, you look for, you go online, it'll show you the path. But you end up going to SolidWorks and down to a key called dialogues. You rename that, and then SolidWorks opens all the dialogues in the default position, because that key is where it remembers all where you closed this window, where you closed. It doesn't help. That's why it took me so long to figure out. If you close this window, even if you reset the dialog box, the default, you close this window, it'll still open up in the Never Never Land. So you're going to see me dragging them on and off to the monitor, where if it closes in that monitor, it reappears in that monitor the next time. Kludge, sorry, got to deal with it. Tool Crib 1, see, this is another oddity of this program. It doesn't show you Tool Crib 1, you select it, it's empty. I assume that's so you can populate it with the tools on your tool holder or in your tool crib. They call it a tool crib. In essence, it would be a tool holder of a machine, and there'd be a tool crib with all the tools that you have in the shop, but that's software, so you're going to have to deal with it. Okay, Tool Crib 2, here's all of that. Oh, don't close it here, Paul. You'll be suffering for a week. I got to go over here. Okay, good. So, let's go to the Feature tab. The next thing to do, we're going in order, I'm sorry. Coordinate system. A lot of tutorials, they'll put the coordinate system of the part in the front corner. In general, machinists don't do that. I drank enough beer with enough machinists and watched them work long enough. You put the part 0, where the G codes are 000, you put that at the back of the vise where the fixed jaw of the vise is. So that would be back here. Most machinists prefer it on the left, because then they put a tool stop, a work stop gizmo to the left of the vise, and they slide the stock on, hits that stop, and then it causes some problems because a lot of engineers want to think of X being in this corner and going down, but that's not smart. You want the part 0 to be reference to the fixed jaw of the vise. So that's back here. This goofy thing, normal stuff. Here's where I say the stock, not the part bounding box, which isn't, but the stock bounding box. And I've expanded this stock. Here, these axes, this is where you flip. You can say, where do I want the X? Where do I want the Y? Where do I want the Z? So you pick one, and you pick just like an edge, and that helps you line it up. I've got to have X off to the right. That's how my particular machine, an Avid Benchtop Pro, Y goes to the back because it's a router style machine. Z is up like most machines. So that sets that up. Let's close out of that. Life is good. Stock Manager. This is the first place where I started getting really exasperated. I'm not gonna, all this is tediously typed in by hand. In general, you say stock type, you can go by a bounding box, you can go by an extruded sketch, we'll show that in a different video, STL file, stereolithography, or a part file. So if you got a solid part that you want to draw up as the stock you're starting with, you can put that in. I had problems with that because it lines stuff up directly and there was no way to relatively move them, or at least I haven't learned how. Like I say, I'm not experienced. If you load default, it just does the mathematical bounding box and gives you really funny numbers when you go down here to the X, Y, and Z. 2.13. Z is 1.68. You don't buy stock like that. Maybe programmers don't realize it, but machinists do. You go to, I like Midwest Metals, Online Metals. There's 3-4 shops. You can order metal from, get it delivered to your house if you want. You buy 2x5 by 2.5 and have them cut it into 10 blocks, 2 inches long. There's your stock. So I had to go, this is the first exasperation. Okay, go up here. They don't let you say, well, pick the stock size and then fit the part in the middle of it. They don't do that. So then you got to tediously go here and start adding numbers and get the calculator out so that you end up with a normal stock size. Maybe that's only because this is the basic free version. Maybe this is improved in the $2,500 package, $3,000 with maintenance is Solidworks CAM Professional, equal to CAMWorks Premium. It gets you volume mill, which is an adaptive machining thing that constant tool loads, goes hogging through metal real fast, supposed to be cool guy stuff, similar to eye machining with Power Cam, Smart Cam, no. It'll come to me. The eye machine, they'll be mad. Smart Cam, no. Anyway, Volume Mill, my machinist buddy said it's a third-party company that sells this adaptive machining to a lot of different cam manufacturers. I don't know if that's true or not. So you get the part centered in the thing, tediously as it is. Now you've got that done. So now you've got your manager setup, mill setup. This is a little confusing to me. You're going to create setups here, and when it does automatic stuff, it's going to create a bunch of setups. Setups is where how you've mounted it in the vise. Setup 1, you're cutting from above, and maybe you're doing this. Then you flip it over and call that setup 2, and you got to find a part 0 and relocate stuff, and it's always a chance for error. If you've pulled it out of the vise for any reason, when you put it back in, there you could be a few thousandths, or the one thing happens, a chip, it goes on the parallel where you're setting it. You set the part on top of the chip, now it's 5 thousandths off. That's why good machinists slide it along the parallels to hit that stop, so they're sure it's down and it feels good. So you got that problem. Okay, setup, mill setup. Of all the goofy things to default to, it does the front plane, maybe because it's the front. This shows that the tool would come in from this direction down, and it would do the side of the part. Not a sensible thing. So let's see, front plane. Pick this face there. That's sensible for the first setup. Let's say you've decided to machine this top part first. So now the little red arrow is coming from above, meaning you'll come down on it, and so it knows that. So now it's created part mill setup 1 here. Same confusion. You go over here. It's a little more sensible because they show group 1 in brackets afterwards. So that's the difference, how you can tell the difference between these two tabs at this early stage. Now you get to the automatic stuff that they brag about and software guys love and middle managers love because they think you can replace people. I'm sorry. The problems I had might be because I'm a newbie, but you watch what the newbie does and see if you'd have these same problems. Extract machinable features. See, they haven't lit up operation, they haven't lit up toolpath, they haven't simulation. These buttons, because first you got to have the program find the features. You can do all this by hand, and I will be doing it. This automatic stuff for me causes more problems than it solves. But let's go through the design intent and see. Extract machinable features, and it thinks a dialog box popped up. I can't move it. It's on one of the monitors. It's off. You guys can't see. Sorry. So now in the features, it's created all these features, a face feature. And I should mention, it only created a face feature. I had to turn that on. It doesn't default automatically recognizing features. A perimeter, once again, they don't default to recognizing perimeters. Why? Once you do it, you'll see when we go through this. It'll do the perimeter from the top setup, then the bottom setup, which is 3, I think. Yeah, from this setup down here, it does the same perimeter, cut and error. Matter of fact, it spends a lot of time cutting error, and it's especially infuriating because this is a very sophisticated program that can do what they call rest machining. And that's where you use a big tool to hog out a pocket, but then you can't get in the corners because the diameter of the tool is too big. So then it's smart enough to say, okay, I'll get a second tool and a smaller tool, and I'll go and finish those corners, but I'm not going to go do the whole thing where there's error. I know just where there's material left, the remaining rust material, and I'll go finish that up. Meanwhile, the fundamental way the program works, it'll machine error all day long. So I'll show you where that is. Tools, got to go up. God, why the scroll wheel doesn't work in these dialogues is horrible. Solidworks CAM, down to options. Once again, this is one that opens on the imaginary monitor if I close it here. So I got to drag it on for you folks. Mill features. See, it comes with face and part perimeter turned off. So I've turned them on just to show you the effect. Oh, don't close it now or it'll never, be a half an hour to find it again. Okay. And it's done the top. It's done the perimeter. It's done the 6 holes. It's done the big hole in the middle. Part setup 2. Okay, here's where it's goofy. This is why they default perimeters off. So when the middle manager shows the CAM middle manager shows the machine shop middle manager how wonderful the program is, it doesn't do something insanely stupid like this, which is it needed this setup to drill this set screw hole. But look, it wants to cut the entire perimeter. It's not a killer. You can go erase all this. But then if you automatic feature recognition again with that turned on, it's going to go add them all back in. So if you use it at all, I think the theory is you use automatic feature recognition once. If it goes crazy and makes these stupid features, just erase them out, but never press automatic again. And be careful. There's a thing about regenerate. You know, like I say, this to me, the program fights you more. Okay, and then the feature is this hole. Face feature, faces off the bottom, which is good. Does the perimeter over again. Total waste, right? This is all in error. You've already cut the perimeter from the top. Open pocket, rough finish. Oh, okay, it's doing this undercut. So it does all of this. Now, okay, this time I added face feature once and it screwed up because it put the face feature after the holes. It did it, you know, it left these here. And when I said, oh no, turn on face features, it did. I recognized automatically. It put it down here because these were already existing, and that would have crashed all of your center drills and stuff. Because the first thing a machinist does is the facing and get the part down to get the stock down to where the part starts. All right, no crisis. Now there's nothing filled in, right? The setups are all empty because why? You haven't generated the operation plan. That's the next software invented concept of, okay, you got features. Now you're going to automatically make, not toolpaths, that's the third button. You're going to make all the things needed. You know, so a drill feature will call a CAN thing where you center drill it, and then maybe you peck drill it if it's deep, or just shoot it through if it's not. All of that complexity is controlled in the technology database. And that's a monstrosity. Let's say tool, SolidWorks CAM, technology database. Oh, it opened up on the same screen for once. Mill. This is where what kind of mill. I should be filling all this out for my mill, but it's not important. When I was doing my mill with a 24,000 RPM spindle, I kept getting exasperated because it kept reverting. I type in 24 to go down to 12. That's because the technology database is in control. You're not in control. Okay, so let's close the technology. Oh, and it's insanely complicated how all the different things. Okay, that's the mill specifications. Turret. See, it says it has a tool changer, and I don't. Spindle. That's this stuff. And this is just the machines, right? There's feeds and speeds. It gets feeds and speed editor. Oh, geez, that opens up over here. You watch the tutorials, you get dialog box dizzy watching this stuff. But it's so powerful. See, this might be because I'm a new guy, right? And not a machinist. I get intimidated by all these dialog boxes paved with numbers. And I'm an engineer. I should love it, but I don't. So now, generate operation plan. You've done the features. The features show up in the feature tab, feature tree tab. Over here in the operation tab, nothing. Now I'll leave that lit so when we generate, you'll see it work. Buzz, 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 it's thinking. And wow, it did all the operations needed to make those features that it recognized. Face mill, rough mill, contour mill, center drills. I'm sorry, center drill 2, that's for the center hole, the big hole in the middle. Drill 2, probably be interesting to see if it decides to peck drill that thing, but it's so big you probably don't have to. All of this decision making has been decided for you in the technology database. And yes, you can change it, and hopefully that doesn't change a part you made last week when you go to remake it 5 months from now, that since somebody edited the technology database to recognize things different. I don't like this whole paradigm. I prefer to do separate, understand each and every operation, understand the program intimately. It's up to you. Rough mill, this is this goofy, it's doing the perimeter, right? It wants to go around and cut the part out. Crazy. Contour mill, center drill. Okay, now it's doing this stuff. Drill, contour. It runs a chamfer around. It does some pretty cool stuff. Face mill on the bottom, rough mill, perimeter, which is all air. This perimeter has completely been cut off. And oh, here's a warning. Go to the perimeter. Where is it here? Here? Yeah. the fact that it shows it starting up here going, it would cut all the stock off, which means how do you hold it in the vise? This would crash into the vise if you let it. Danger Will Robinson. But even sillier, over here, it does a rough and a contour all in air because it's all been cut off on the top setup. Now you're doing the bottom setup from when you flip the part around in the vise. Okay, rough mill. This is the undercut. It rough mills. So this is where the technology database is kind of cool. Well, let's do a rough and a... It's funny, it's rough and finish in my book. They call it rough and contour. Maybe everybody does. There's a rough mill, open pocket. Right? Now there's no tool path. You don't see the spirals and where the tools are going yet because you haven't generated the tool path. So I click on that. It thinks there's a little dialog box that's hopping off on a monitor you can't see. Sorry, I've tried to move it. Now you see tool paths. Now that's pretty cool, right? It's going down there. It's cutting those tool paths. Contour mill. It's cutting all those tool paths. Rough mill. And it's nuts. I shouldn't gripe so much. When it does this whole extra perimeter on the bottom in air, you can just right click and delete it. It's not the end of the world. It goes in the recycle bin. You can even call it back if you want. This is concerning. Contour mill here. Counter bore hole. When it's blue, important thing to learn, remember, if it's blue, it means it ain't doing anything. So if you have features that are blue, that means you forgot to generate an operation plan for those features. Generally, that's what my mistake was. Why this is blue, it means there's no tool path generated for this. And I'm not sure why it failed. A week in the technology database, I might understand. The tools, here's a good tip. Now, the face mill, right? Let's do this real time. I think you'd be impressed. This is what's cool. So it's got a big face mill, right? You can see defined and you simulate it. But you don't want a face mill. You don't own it. I don't have the torque. My little machine doesn't have the torque to run some big 2-inch face mill. You can take it here in the Tools tab, up here, SolidWorks Tools tree, and let's light up. There's a 1/4-inch end mill, which is the only tool I want to use in this little Avid. Come up here, drop it in. Come up here. See? Automatically, it changed the tool paths for a 1/4-inch end mill. That, I think, is pretty cool. Let's go back to here. Let's go to the face mill. Face mill here. Same thing. That's that big face mill. That's this face mill, right? Lit up. Drag it up. Cool. See? And I'm not sure if the order here matters. Putting it up. Oh, it's not letting me move them. That's interesting. But definitely over here, you want to face the thing first. Let's see how it did. Mill part setup 1. Face mill. Good. I did this once as I was playing around to rehearse getting to show you this. Because I didn't have face mill automatically recognize checkbox. When I did check it, it put the face mill at the end. And then in the simulation, you got to know how to set some stuff because it looks normal, but really it's crashing because it goes to do a center drill of this surface here, but you haven't faced the top of the stock off. You haven't got down to this surface yet. So this is cool. They're smart enough. If you have that checkbox in the SolidWorks, CAM, tools, feature recognition, if you have that checked, it puts face milling first. There's that contour mill, something about that it didn't like, I don't know why. And then mill part setup 3, face mill first. Good, this will save us a few crashes. So now, without touching anything, it's obvious to a machinist that this won't work. You machine through the vise, but there's worse problems. Now, because we did generate toolpath, this is lit up. Simulate toolpath. You go here, and it lights this up. And let's go really, really fast. How much time we got? Oh, 24 minutes already. There's the 1/4-inch face mill. Here's the perimeter. Let's stop it. Stop it. Notice that the tool is crashing into the part. You've just got yourself a $15,000 spindle and probably a job if you work for other people. This is because default, it sets tool ignore collision, tool shank ignore collision, tool holder ignore collision. And what you're allowed to do is you say, oh, cut it. If it goes there, take that material away so that when you do this thing and check the part to see that it's made the way you want, that there's all this missing stuff. Or you can pause on collision. Let's see what happens. Pause on collision. We'll stop the tool. Here we'll cut. Here we'll cut. Okay? And we'll go back to the beginning and oops, come on. Here we go. We'll see if it crashes a tool into the rough stock. See all this stuff, all that blue? That's because the tool holder is cutting that. That's not the tool. Now it's doing the finish pass. It's cut all the way into the vise, all the way to the bottom. Now it's doing this goofy perimeter around the outside. Now it's facing the bottom with a 1/4 inch. That was really cool. Now it's doing the perimeter from underneath, which is all in air, hitting the stock again. Now it's doing a roughing, and now it's going to do finish of this barrel itself. There's a finish, and it's done. Then that's the other hard thing to understand here is, what's this? Select chips and press. One day I'll have to read a book and understand what the heck they mean, select chips and press Control D. It's an option, collisions, who knows? This is the Magilla. This is all that's left of that part after the tool holder cut everything away. Not a lot. That's kind of concerning. So let's go ignore collision, ignore collision, ignore collision, which you'd never want to do if you had half a brain. And go all the way back to the beginning. Let this thing go nuts again. All this is fixable, right? You got to use longer tools. You got to do, but do you want to go change the technology database? I don't know. I don't. I'd rather just work tool by tool, feature by feature. Okay, it's done. Now we'll go light this thing up. See? This tells you if it's green, that means it's right on the money. It's exactly where in space the design intent of the model was. That's really good. And I'm pretty sure it's green. Oh, look, there's a little blue. That's interesting. So something didn't, that must have been that operation. Maybe it didn't have the right tool to do that. That's what's going on. Ta-da, hey, we've thought this out. The reason that's blue, I'm sorry, I can't. TurboCAD zooms scroll wheel one way, SolidWorks does the other. So that's blue because it's over, which means it didn't get cut because it got through drilled, but they didn't want to use a tiny little end mill and do that. Now that's pretty cool. So that's first impression video. Let me tell you where I think the program is aimed. This whole CAMWorks, whether it's the free one in SolidWorks or, I should mention, the reason I can't use it, it doesn't have a perpetual license. The free version, if you don't pay your SolidWorks maintenance, it dies. The CAMWorks dies. SolidWorks is perpetual, so you can use it 20 years from now. But CAMWorks will stop working if you're not paying your maintenance. Now you go up a grade, CAMWorks Premium, same as SolidWorks Professional. I think that's about $3,000, let's say, with maintenance. That gives you volume mill, still not 3D, but I think it's perpetual. And then if you go into CAMWorks Mill package, that's 3D. It's $5,500 plus $1,500 maintenance, $7,000. A little more than I want to spend. I can't afford the real high zoot Mastercam. Can't afford Mastercam, Esprit, Gibbs Cam. I call the Hyperloop guy up. Well, give me an idea. Nobody tells you the price. It's like used cars. I said, well, look, if it's over $10,000, I'm not interested. So he said, it's around $10,000. So Hypermill is out. I thought I wanted a package like Hypermill, Visual Cam, it's a cheaper package, Bob Cam, the cheapest, CAMWorks. No, CAMWorks is this one. Solid Cam. That's the German company that makes iMachining. Okay. Because they all work in the SolidWorks window, right? It does stuff like this, adds tabs. After realizing how clumsy the SolidWorks interface compared to the old CAD key days, like one CNC cam works, it looks like a CAD key. Looks much simpler, and you can bet I'm going to try it, even though I got to pay for it. and just to try it for 30 days and ask for my money back. That's to me the one that looks best now, just very cursory going over stuff. So to me, in this mid-range market, $5,000, let's say, or less, something like this with this technology database, if you got a company with 12 people, 11 of them are button pushers. They stand in front of the machine, a setup person, she sets it up. All the button pusher does is press the go and watch the machine and maybe change the part in the vise. Button pushers. You got one ringer. She's the programmer. She's a setup person. She's the machinist. Now you're going to want her to be a database administrator too. So you buy this program. It doesn't, it does these problems. The button pusher goes to your ringer and they tell her, hey, this, it's crashing. The simulation, once you teach them about those buttons, simulation is going to crash. I'm not even going to put it in the machine. Then she'll go into the technology database, do all the work, say, oh, when you see this feature, do this. Or she will do it manually for them and give it back to them, right? And she'll get more and more overloaded and eventually quit in disgust. For me, I'm an engineer. I'm not a machinist. I don't have a shop. I'm not doing production work. I'm doing prototype work. I don't need the technology database. To me, it seems like I'm fighting it. And the next video will show some of this is trivial to fix. I shouldn't gripe so much. Oh, it added a perimeter cut that in air. I'll take it out. Right click, delete, gone. But then what's dangerous, as I've learned, is, if you auto feature recognition, it'll go right back in and put stuff back in that you took out. It's not smart enough to know, hey, I already took this out once. So it's to me as a new user, it's very powerful, very exasperating. So that's my take on it. Second impression is going to be, let's take this part, which I just grabbed out of the air, and let's try to see if we can fix it, especially now that I realized why this is blue, because it didn't have the right drill. So we'll go through that. I'll show you how to erase the stuff, and let's do the way this thing will work. Ultimately, maybe I'll make a third one where I just do everything by hand and don't do any of this automatic stuff, which is not in there. Don't do any of this ribbon bar stuff with the extract machinable features. So we'll be back with that. Shouldn't take too long. I got it all set up. I'm in the studio here. See you next time. Good luck with your CAM adventure and have a nice day. Thank you.